Hello, this is the video for lesson 6.5 out of your textbook, Probability of Disjoint and Overlapping Events. As you can see in your notes, we have three different types of compound events. We have the intersection of A and B, where if I was going to color A, color B, you can see that you have this shaded shared area right here. And we have already done several probability questions with this situation where we typically just use a sample space. And today what we're going to do is we're going to talk mostly about the union of A and B, which is the same thing as or. And the third one is mutually exclusive or disjoint events. Now, the big difference between the one in the middle, which is the union, and the mutually exclusive is that sometimes you have shared parts and sometimes you don't. So in a mutually exclusive event, you don't have anything that is in common. So what you would do is you would modify your formula slightly. I'm going to tell you right now, if you use this formula every time you have an OR event, you will be perfectly fine. If you actually choose this one over the other one, you will not be fine because this one only works for very specific mutually exclusive events. This only works when you don't have anything in common. So what I suggest is I would absolutely use this one every single time. There's no harm in using that because if you don't have anything in common, you're basically going to be subtracting 0. So it's just kind of a catch-all. So you need to use this formula a lot. Okay, so let's talk about some examples on when they would have something in common versus when they don't. So in a standard deck of 52 cards, what's the probability of picking a black or a face card? So there are going to be some black cards that are also face cards. Like you can have a spade that is a joker. You can have a club that is a king. So you do have to have a little bit of knowledge about cards. What you need to do is you have to think, is there any kind of overlap to it? If there is any overlap, you need to make sure that you include that into your formula. Over here in things that are mutually exclusive or disjoint, you're not going to be able to have any overlap. So an example of that would be picking a diamond or a spade. So is it possible to have diamonds overlap with spades? No, because diamonds are their own and spades are also their own, so you don't have anything that's overlapping. You don't need to have this extra little part of your formula. You can just simply add the probability of getting a diamond and the probability of a spade. Since there's no overlap, we don't need to subtract the probability of both. Let's go through some examples. So what we want to do here is figure out what would be best. Should we use our sample space? Should we use a formula? If I'm going to use a formula, do I have any overlap or not? So there's two things that we need to look for. Is it an and, or is this an or situation? So I can tell right now, it says, what is the probability that it is red or green? So I'm going to go ahead and set it up. I'm going to say the probability of red or green. Since it's not an and, I'm not going to use a sample space. I'm going to go ahead and use the formula, but which formula should I use? Should I use this formula or the one that has the probability of A plus probability of B? Well, we've got a box. We have 2 red, 4 green, 5 blue, and 3 yellow marbles. If we're trying to figure out the probability of drawing either a red or a green, what you need to do is ask yourself, can the marble be red and green at the same time? Do you have a shared space here? We don't. The marble can't be red and green at the same time. So I'm just going to simply say the probability of the red plus the probability of the green. Now, if you make a mistake and you think that they have something in common, this will not hurt to put here, okay? And I will show you why. So the probability of getting a red marble would be 2 out of, well, we've got to add these up for our total, right? So 2 plus 4 plus 5 plus 3 gives us a total of 14. So 2 red out of 14 total plus 4 green out of 14 total minus how many marbles do I have that's red and green? I have 0 marbles that are red and green. See how that doesn't really affect your outcome? So final answer will be 6 out of 14, which reduces to 3 out of 7. Okay, so for the next question, we have a math class of 30 total students. We have 17 that are boys and 13 are girls. And on a unit test, 4 boys and 5 girls made an A. If a student is chosen at random from the class, what is the probability of choosing a girl or an A student? So let's go ahead and set this up. So the probability of choosing a girl or an A student. That just means that they made an A on that test. Since this is an or situation, I can use a formula. So I can go ahead and do the probability of girl plus the probability of getting an A on the test, and I could subtract the probability of getting both. Do I have that possibility? Can I have a girl make an A on the test? Absolutely. It actually said that we have 5 girls make an A on the test. So this one does have overlap. So we have girls, and we have making an A, and I have that overlap. If you do not subtract the probability of both, what you're going to do is you're going to repeat all of these outcomes that are shared, and it's going to give you the wrong probability. So let's do the probability of a girl. That would be 13 out of a total 30 students. How many made an A on their exam? You have 9 that made an A out of 30 minus, and we're going to subtract that overlap. So I had 5 girls that made an A. Altogether, type that in your calculator, you want up with 17 out of 30. Okay, so the next example says a card is randomly selected from a standard deck of 52 playing cards. What is the probability that it is a face card? So let's write that down. Or a diamond. Since it's an or, I can use the formula again. So I can set it up by saying the probability of a face card plus the probability of a diamond. And at this point, you have to ask yourself, can you have the probability of both of them occurring at the same time? Can you have a face card that is also a diamond? Yes, yes you can. So we absolutely have to put that part of the formula in to get the correct probability. Okay, so what's the probability of getting a face card? So a face card would be a jack, queen, or a king. And we have 3 for each suit. I'm sorry, I couldn't think of the word for a second. So that means we've got 4 suits. We have a total of 12 face cards. So 12 out of 52. Okay, how many diamonds do we have? We have 13 diamonds out of 52 cards. And what is the probability of them both? So I've got 3 per suit, so that means I've got 3 in the set of diamonds, so it'll be 3 out of 52. Put that in our calculator. We should wind up with simplified 11 out of 26. Okay, same situation. We have a standard deck of 52 cards. What is the probability of selecting a 10 or a diamond? So first question, do I have any overlap? Can a 10 also be a diamond? Yes, it can. So I absolutely have to put probability of getting a 10 plus the probability of getting a diamond, and then we have to subtract the probability of that overlap. Okay, how many 10s do I have in a deck of 52 cards? I have 4 out of 52. How many diamonds do we have? We have 13 out of 52. Each suit has 13 in it. And I only have one 10 that is also a diamond, so 1 out of 52. And if you type that in your calculator, simplify it, you wind up with 4 over 13. Okay, so if we flip it over on the back, we have a two-way table that's helping us organize our information. And sometimes when I have students do probability using the two-way table, they forget about that overlapping condition. So this table has students, ask students if they voted on Friday or Monday, whether they want to take a test on those days, and they divided it up into male and female, and whether they voted Friday or Monday. So we're asking the probability if you randomly select a male or someone who voted on Monday. So you can go ahead and start setting it up. Since this is an or situation, you can do the formula. So it would split up into probability of male plus the probability of Monday. And then you have to ask yourself, do I have an overlap? So that would be both male and voted for Monday. And I do have overlap right there. So the two-way table actually demonstrates that really well for you. Okay, the problem is this two-way table doesn't have any totals. So if I just kind of add across the rows, I get 15 here and I wind up with 11 here, which gives me a total of 26 in the whole entire chart. All right, so the probability of randomly selecting a male, I would have 15 out of 26. Probability of selecting somebody that chose Monday, just add down the column, 14 out of 26. And then you have to subtract that overlap. So I have 8 people that were male and voted for Monday. So type that in our calculator, we wind up with 11 out of 26. Okay, so I apologize in advance that you cannot see the colors on your black and white notes. So here's what I suggest that you do. Go ahead and put Y next to the yellows. I'm going to put R next to the reds, B next to the blues, and G next to the greens. Now, if you go back and look at your notes, you can see what the colors were supposed to be. All right, so all of these have an equal area, spinning a yellow or a green. So we're looking for probability of spinning a yellow or green. Once again, if it's an or, set it up using a formula. Do I need to subtract the probability of both? Do I have the possibility? Is there an overlap of having a yellow and a green at the same time? No. So I do not need to do the probability of both. If I do that, it'll just be 0. It won't hurt you, but you just don't need it. So the probability of spinning a random yellow would be 3 out of 12. And you're going to add that to the probability of spinning a green, and you have 2 out of 12. So total probability would be 5 out of 12. Okay. So next part says spinning a red or an odd number. So I'm going to set it up, red or odd. Since it's an or, I'm going to do the probability of red plus the probability of odd. Do I need to subtract the probability of both? Can I have a red and an odd? I do believe I do. So I do need to leave that in there. So the probability of red, I have 4 out of 12 that are red. How many do I have that's odd? I have 1, 3, 5, 7, 9, 11. So I have 6 out of 12. And how many are red and odd? That's red and odd. And that's red and odd. So I have 2 that are red and odd. So I have to subtract that overlap. So that's going to be 8 out of 12, or 2/3. All right, part C says spinning a blue and a 12. So blue and a 12. So since this is an and, it's easier just to use the sample space, and our sample space is the actual spinner. So how many pieces are blue and 12? I have one piece that is blue and 12. So it's just going to be 1 out of 12, no formula needed. Okay, so in this last regular question here, this is obviously out of a deck of cards. So just remember that a deck of cards has 52 total cards in it. And this Venn diagram shows some very specific things, and we've got some overlap. So you have to be really careful if you're trying to find the probability of or. So if you look at question number 1, it's saying what's the probability of A and B? So that is the literal overlap of A and B. So how many do we have in this and section right here? We have 3 out of a total of 52 cards, and that does not simplify, so it's just 3 out of 52. The second one is an or, so I would go ahead and split these up into 2 different sections. So the probability of A, now you got to be careful if it's a Venn diagram. You have to include everything in circle A. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 out of 52 in A. And then B, here's where that overlap comes into play. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 in the B circle. And then we're going to subtract those 3 that we had in common. So type that in your calculator. You wind up with 11 out of 26. Now there's a neat little trick. If you're very aware of the Venn diagram, and you're really good at this, and if you can remember it, then you can just simply count how many that are in the total Venn diagram section here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So if you just count, you end up with 22 out of 52, which is, guess what? 11 out of 26. So you can always fall back and use that formula if you want to, or you can go ahead and just count everything in the Venn diagram if you want to do the union of A and B. All right, so this last question is for the honors student. So if you're a regular student, you can stop the video right now and go ahead and tackle that practice work. Okay. So we've got an archaeology lab receives 150 artifacts for processing. So that's going to give us our total. Out of that total, 108 are either made of clay or have coloring. So I'm going to make a little note here. So clay or color is going to be 108 out of 150. There are 81 artifacts made of clay, and then I have 34 artifacts that have coloring. What is the probability that a randomly selected artifact is made out of clay and has coloring? So it gave us the information for the or, clay or color, but not the and. So what we can do is use the formula for the or to help us find the and. Since this is an or, you can split it up in the probability of clay plus the probability of the color, and you have overlap. So it'll be probability of both, which is exactly what I'm looking for. So I'm going to highlight this because I don't know that. That's what I need to solve for. I do, on the other hand, know the probability of clay or color. That's 108 out of 150. The probability of picking a random clay item would be 81 out of 150. The probability of picking a random color would be 34 out of 150. And then I'm going to subtract the probability of both, which is what I am looking for. So just do a little bit of simplifying using your calculator. Add these two together. You wind up with 115 over 150. Go ahead and subtract 115 over 150 from both sides. You wind up with negative 7 out of 150 equals negative probability of both. And just pretend that's a variable and you want to get rid of this negative. So you divide both sides by negative, which changes this to positive 7 over 150, which gives you exactly what you were looking for in the first place. And that is it for this lesson. Just let me know if you have any questions and have fun with the practice.